Good evening, everyone. Before we begin, let's pause to reflect on the fact that we reside on the lands of the world's oldest living civilization. I pay my respects to the peoples of the indigenous nation, the traditional custodians of the lands where I am streaming this event from. I acknowledge the traditional custodians of the various lands from where all of you are watching, and all Aboriginal and Torres Strait Islanders peoples participating in GovHack. I pay my respects to elders past and present and celebrate the diversity of Aboriginal and Torres Strait Islanders people and their ongoing cultures and connections to the lands and waters of Australia. Today's topic is Bring Your Internet of Things Insights to Life. We have two presenters. They are Michelle Howie from Telstra and Valeriia Savenko from Microsoft. I'm happy to see you girls today on our live stream. So you can take the moment and speak about your topic.
Sure, thank you so much. I'm going to get started today. It's so great to be here at GovHack in 2021. I am Michelle, and I'm actually Telstra's developer advocate, and I'm presenting to you from Adelaide on Kaurna land. I'd like to acknowledge the land that I'm meeting on today and the land that all of you guys are meeting on, but also the lands on the data, which is taking this video and this voice from me to you, all the data centers along the way and all the lands that it is going through. Today I'm joined, by Val from Microsoft, and she is the Microsoft Australia and New Zealand IoT lead. And together we're going to set you guys up for a successful GovHack submission. So Telstra and Microsoft are working together this GovHack, and we're going to help you to be able to harness the Internet of Things to bring your data insights to life. So the first 20 minutes, I'll be talking to the sort of Telstra side of it, which is the networks engineering lens. I'm from a networks engineering background myself, and I'll be talking about what IoT connectivity makes sense for different applications. So I'll be specifically comparing narrowband IoT and 5G, but I'll also touch on some other IoT topics. Maybe in the chat, you guys can let me know while I'm getting started what other IoT connectivity we could possibly have. So 5G is one. What other networks could you use to connect the Internet of Things? After I've done that, Val is going to show us how we can actually take all the data coming over the network and make sense of it through Azure IoT. So you can ask questions at any time, and we'll be checking into the YouTube chat feature. But if you're watching this as a recording, please, you can jump on Twitter. I've got my Twitter and Val's Twitter and our company's Twitter there. Stay connected with us. If you think of a question later, post it in the Slack group to GovHack. We're both going to be in there answering your questions. So without further ado, IoT is the Internet of Things, and it's connecting billions of devices to the network. So the IoT provides a tsunami of data across all industry verticals, but not all IoT networks are created equal. So we have narrowband IoT, we have 5G, and then Val is going to talk about Azure IoT. So IoT. There are already actually more IoT devices than people in the world. And that's actually going to increase probably about 5-fold in the next 5 years. I've actually heard that there are more cows connected to the internet than people already too, which is something crazy to think about. But IoT is about connecting data. It's about analyzing that data and then using that data to automate some systems to solve problems. So what kind of problems can we solve? I'd like you to think about these when you're thinking about your GovHack open data challenges. It makes sense to implement IoT where the activity is too dull or too dirty, too dangerous or too distant for humans. Now, there are many reasons why you could connect IoT to other things, but these are kind of the key use cases that I like to think about. Some of the things that you can do with the IoT is save energy, save time, save money, and make things more safer and more entertaining. And this will impact us all on an individual level, whether it's reducing your electricity bill with automating lights that dim if no one's in the room, or at a different scale, at a more industrial level, resources that could be saved and lives that could be saved are extremely exciting. And here's an example of when you can use the Internet of Things for something else. So I've got a little augmented reality shopping example here, where it's actually taking information from the shopper. It could be using their gender or their demographic or something else that the shopping knows about them to change what they see. So that's a little bit scary, but there's so many other ways that you could use IoT paired with other real-time information. That's when it gets really exciting. All right. So when you think about the Internet of Things, there's three main things that you need for them to be connected. So the first thing you have is devices. You need to have devices. These devices could be anything. They could be like a virtual reality headset that's streaming gigabits of data per day or per second even. It could be a robot that's doing the cleaning, so it's sending a few megabytes of information every week. Or it could be something as small as a water meter that's only sending a few kilobits of data every month. And you do need a different mobile network for each of those applications. And that's the next part of the IoT, is the network. So you have the devices, you need to connect them to something to get the information out. So I've mentioned already two kinds of IoT networks. We have narrowband IoT and 5G. Some other ones that you guys will probably think of, you've got Bluetooth, you've got Wi-Fi, you could potentially use something like satellite, or you could even wire them together. So obviously traditional wired. And there's other non-standard technologies like LoRaWAN, Zigbee. And the network that you choose depends on so many things. So maybe if you guys think of them, maybe you can post them in the comments. What are some other things you need to think about when you're choosing a network? In the example I just gave with the VR headset and the water meter and the robot, depending on the amount of data you need to send, how fast you need to send it, where the data is going, how critical that data is it a life or death situation, or can it come in a few minutes time? That really depends, and I'll give you some examples, some more examples later on how you choose which network. But the last thing you need is actually an application to make sense of that data. So I'm going to leave that bit to Val from Microsoft after. But you really need to think about these three things when you have an IoT solution. So when you're thinking about your GovHack submission, think about these things. Remember, data can go two ways. So we can go from the device to the application. So for example, you might have a water meter who's saying, hey, my water tank is empty, sending that information to the application. The application can then take that info, push it back to the device. Okay, water meter needs to be refilled, turn on the pump, and it can actually actuate that data. So there's two ways of data. And that is also another thing you need to factor in when choosing the network that suits your IoT use case. So I'm about to go through two different IoT use cases, and I'm going to show you how they match the network that will enable them. All right, what have we got here? Some train tracks. This is one of the most impactful examples I've seen of IoT lately. It's from a customer who Telstra dealt with, who faces significant weather-related delays in their supply chain. So they have a train that travels from the mines in the centre of Australia to ports out at the ocean, where they're taking precious loads back and forth, travelling thousands of kilometres by train. So when these tracks are too hot, now it's hard to imagine now in the middle of winter something being hot, but these train tracks can get to up to 60 degrees Celsius, right? At that temperature, they start to warp, they start to change shape, and it makes it really hard for the train to stay on track. So the train has to actually slow down to be safer. So the train driver has to kind of guess, based on the nearest weather station, how hot the track is going to be, right? And I say guess because those weather stations could be hundreds of kilometres away from where they actually are. But every, tens of kilometres per hour, they cut off the speed of the train, they lose hours of time in the long run when it takes, going from the mine into the port. So that the cost of that delay really adds up. So they would like to know with certainty how hot the track actually is at that point. So that minimises them, overestimating and going too slow, or underestimating and having an unsafe trip. So you could put a few well-placed sensors along the train tracks and have a smart dashboard maybe in the train driver's seat to see what the temperature is, how fast they need to go. They could use some sort of smart AI to make that decision. So some of the considerations you need to make for this use case when considering the network is you need to think about the power consumption. So here, you don't want to be going out into the bush to your thousands of sensors every couple of days to change a battery like you would with a cell phone, right? So you need an IoT network that uses low power. You also need to think of the cost. because the scale of these number of devices, the number of, say, SIM cards or gateways you have is in the thousands. So you don't really want to be paying a lot for each device and the network costs of each device. The third consideration here is the coverage. So how far, where is your train track? Is it in an urban area? In this case, it's out in the regional areas actually. So in these cases, we don't even have 3G, let alone 5G. So that will make a big difference in the network that we're able to actually choose. So the network that I would recommend in this case is low power, wide area cellular network. So that's a mouthful, but LPWAN is how we say it for short. At Telstra, there's two kinds of low power WAN networks we have on our cellular network. Those are LTE-M or Cat-M1 and narrowband IoT. So I'm interested to hear if you guys have heard of these before, or if this is something new, but it's something to consider when you're looking at your GovHack submission. Okay, so the exciting thing about these networks is there's a trade-off, right? Because you have lower data requirements, you need lower power. Because you have lower data requirements, you get lower power, is what I mean. So you don't need to have, like, you imagine a phone has a really lots of things going on in the phone. This little device that's saying the temperature doesn't need a lot of power, which means you can actually go a much further distance from the cell tower. So the Telstra's narrowband IoT network has about 4 million square kilometres of coverage in Australia, which is significantly more than 4G and others, which are mostly in urban areas. So these devices can connect 120 kilometres from the tower, which is great in regional areas, obviously, but also in urban environments. So think about places where you want minimum maintenance, you want the battery to last a really long time. So actually Telstra has devices in the Melbourne CBD that are about 5 metres underground, sending telemetry data and temperature and things like that. You don't want to be pulling them out to change the battery and shutting down the roads every once in a while. No, thank you. So that's for remote monitoring. And with these networks, because they're cellular network, they're not non-standardized like Wi-Fi and LoRaWAN and things like that. So they have inbuilt security over the network. So the data you're sending is sort of encrypted on across the network, not just at both ends. If you want to know more information about that, jump into the Slack, the GovHack Slack channel, and you can message me and ask more about that. So the next use case I have, I wonder if you guys know what this is. Of course, it's a drone. So I'm sure you can think of a great use case for drone. I think I heard Amazon a few weeks ago releasing they've started drone delivery door to door, which is crazy. So I might be seeing more of these. Telstra actually uses drones a lot, especially in things like emergency services. We can send actually little cell towers on drones out. They call them cell on wings. But I've also seen these when I used to live in the Gold Coast as sort of doing surf life saving. So they can go and do like shark spotting using AI to see if there's like a shark in the water, or the lifeguard can send out, instead of, getting on a jet ski or whatever, they go out, they can send the drone out with life rafts and things like that. So drones are pretty cool. Anyway, sorry, too much about drones. But when you think about these saving lives, the first thing you need to think about is the low latency. So the kind of use case that drones do is kind of mission critical, right? The time it takes for information to go from one place to the other, which is the latency, the time taken, needs to be sort of near real time because there's lives depending on it. These drones also need to be really light. So they need high data rates because you can imagine when you're zoomed up really high, you need 4K, 8K, ultra HD vision on the cameras that are on the drone. So you need high data rates to send that, because if you're going to do some sort of AI programming, so for example, the shark spotting, you can't actually strap like a gaming PC or like a gaming laptop onto these drones. It's way too heavy. So all of the AI and processing needs to be done in the cloud. So you need to get that 4K, 8K live stream from the drone into the cloud. You need high data rates, right? These drones, unlike the train tracks we were talking about earlier, these drones are operating in urban areas where it's highly congested. So think about this picture. You've got smart buildings, you've got smart car parking, smart cars, you've got smart lights, you've got people with their phones and their watches and their glasses and everything going on. It needs to be able to have higher priority in congested areas. So what network would we use for this? I think you guys are going to be able to guess the answer. 5G would be a great use case for this. So that's what I would pick anyway. Here's a little picture in the 5G Innovation Centre up on the Gold Coast where I was before I came into this role back in Adelaide. But I want to ask you guys, what do you think the G stands for in 5G? And there's a reason why I'm asking this. Some people might think the G stands for things like, actually, you know what? I won't even give any clues. I'll let you post in the chat or message me. But I'll give you the answer anyway. The G stands for generation. So 5G is the 5th generation of mobile network technologies. And it's actually the first generation of mobile networks that was born in the era of IoT with the Internet of Things. And so all those things I talked about before, the low latency, the high data rates, and the congested areas, all those things are tackled with 5G, which makes them sort of the new generation. I'll just quickly go over the evolution of mobile networks and how we kind of got to 5G. It'll help you guys understand and make sense of the road that we got to get here. So the first G, 1G, was about voice calling. With 2G came about text messaging. So as the population of Australia started, well, not Australia, but the world, right, started growing over time, 2G overcame the congestion and security concerns of 1G. SMS was kind of a gimmick at first. No one really thought they'd be using SMS, but how wrong they were. 3G came about when we were looking at things like news on our phone. So in 2G, it was just calls and texts. 3G, you could actually open an email on your phone. You could open Facebook, but you couldn't really get like the high definition photos. You definitely probably couldn't watch videos on 3G with the rates that they had. That's when 4G came about. So when 4G was rolled out, the 4th generation of mobile network technologies, we were able to then get higher data rates and then be able to use video. So when 4G was first launched, Netflix was actually a DVD delivery company, right? To give you an idea. They couldn't even imagine doing it online and streaming it until after 4G was released. So that sort of gives you a clue to that. When we've launched 5G, so Telstra has 5G across Australia. Now all these cool use cases and the new Netflixes can come about. So 5G brings with it that connected society, which is the Internet of Things. More immersive experiences, real-time control, massive connectivity and bandwidth. And this is a kind of an evolution. So we're not quite there yet. We've launched 5G and we're sort of moving through then. And if you guys want to know a little bit more about how 5G will actually achieve that lower latency, the double-digit gigabits per second downloads, and all the other things that this next generation will give the ecosystem, let me know. There's cool things like network slicing and 5G core, and lots of other technologies that go behind that. So I won't talk about them today, but definitely let me know if you want to hear more. Oh, yes, this is my favorite. So just so everyone knows, 5G removes bottlenecks in speed, bandwidth, and capacity. So for things like drones, makes them a lot easier. But those bottlenecks may still exist in other parts of your network, in your end-to-end tech ecosystem. That's why you need to optimize with things like cloud computing. So like I said, with the drone, you're not going to have a gaming PC strapped to your drone. You're going to have that in the cloud somewhere. So I'm going to leave our expert Val from Microsoft to talk a bit more about cloud later. But you have to sort of combine those things. If your cloud is too far away, you need to think about edge computing. If it takes a long time for you to actually process that data, 5G is not going to help. You need to have artificial intelligence and things like that. You need to have fast devices. So if you're using like a really old device, 5G isn't going to help make that device faster. You need to actually have a faster device with 5G. So these are, and the last thing there, which is what I'm specializing in, is APIs. So at Telstra Developer, which is where I work, we talk about APIs and how the IoT is going to be unlocked by APIs. I think probably the main thing I would highlight here is something that I call digital proximity. So how close is the cloud actually to you? So have a think about that. I'll leave that with you. Have a think about digital proximity when you're looking at your solutions for GovHack. All right, so we've talked about only 2 of the networks that are going to actually enable the Internet of Things, right? We touched on both ends of the spectrum. So we have the low frequency, low complexity, low power networks like narrowband IoT and Cat M1. They're here. And there's some of the use cases that Cat M1 and narrowband IoT will actually enable. And then we talked about the blistering speeds and the scale of 5G that's scaling up performances for things that are a bit more critical, autonomous robotics, right? So Telstra has a range of network technologies, and there are some that are not on here as well. So think about, we mentioned sort of satellite and Bluetooth down the bottom here. You've got fixed NBN, and then you've got other things like LoRaWAN and Sigfox. Some of them have their place, but But again, have a chat to me in the Slack channel if you want to know more about comparing the different technologies. But for the IoT industry to grow in Australia, it's going to require a vibrant IoT ecosystem of developers and hackathon challenges like yourselves to drive change and challenge the face of innovation. As these technologies become cheaper, they become easier to develop with. So we'll see that IoT innovations don't actually require an engineering degree to use, they just require creativity and problem solving. So just as satellite isn't the answer for everything, 4G isn't the answer for everything, 5G isn't the answer for everything, they all have really good use cases. Wi-Fi and Bluetooth are good for really cheap devices that are less critical. 5G is good for something that's really, really important and you need it to be sort of high tech. And these things will all evolve at the same time as 5G evolves as well. And yeah, there are just a couple of the use cases that I had. And I want to bring it back to this diagram I had before, which is how do you actually connect them? So remember, we have the devices. So that's the first ingredient. You have your devices. The next ingredient is the network. So I've just got the little diagram here. To have the mobile network, you need to have a SIM card and a data plan for IoT. And then the third thing you need is the application. So if you have devices with no network, you can't get the data anywhere. If you have devices connected to the internet, but they're not connected to any application, then it's also useless. So I'll leave Val to talk about the next bit in a second. I'll just finish up. This is dev.telstra.com is the Telstra developer website. And here's a little device that we were having to help you test the narrowband IoT network. So GovHack is, I think, 17 days away exactly. So if you have a chance before GovHack, let me know if you want to get your hands on one of these Arduino devices that comes with a Telstra SIM. So you can have a play around with that and test the Telstra IoT network. So it's not available online, but if you just send me a message, then we can sort something out. All right, cool. So, okay, so before I hand over to Val, we do have some questions in the chat that I'll have a look at. All right, so Brett asked about the Slack channel. I'm going to leave that question till the end for the GovHack organisers to come about. So Brett also asked, how long is the battery life for the drones? Well, that depends. It depends on what kind of drone you have, but it also depends on what the drone is doing. So if you have a drone that's sitting up there doing low definition video streaming, it's going to have a longer battery life. If you have a drone up there that's doing high definition video stream, autonomous driving, sending temperature sensors and things like that, it's going to use a lot of battery as well. So it just depends on the use case, and depends how big your battery is, depends how heavy the drone is, whatnot. Okay, someone from GovHack Queensland asked about the cybersecurity concerns for people about 5G. So thank you for asking that question. I'm going to actually ask you to come into the Slack channel. We can have a big chat about cybersecurity. Cybersecurity, anything you connect to the internet, right, you're going to have to think about cybersecurity, because you're going to have to think about, if you have access to that data remotely, someone else could possibly have access to that data remotely. So the good thing about the mobile network, so 5G, narrowband IoT, Telstra's network, they're actually secure network connections with cybersecurity built into the headers that send the information. So I don't want to get too technical, but maybe if you have any specific questions about how you can apply it, definitely come and message me and we can talk about that. But yeah, in general, you have to make sure that whatever you're building is secure at all points of the vulnerability. So no matter if you're using 5G, Wi-Fi, or whatever, the device needs to have security on it. The application needs to have security. So it's a big, big consideration, especially with the IoT. I think when you think about the information coming through the Internet of Things, you might not think that your device is interesting. So you might have a farm that has some, water meters or temperature sensors. You're like, oh, I don't mind if someone hacks me, whatever. But if someone actually had access to that information, they could do a lot of interesting things with that you don't want them to do. So yeah, cybersecurity is always a concern. And luckily, things like 5G have them sort of inbuilt. Cool. So Zaidul asked, what about places where there are no 5G, 4G, 3G coverage? So most places in Australia where there's urban population, you'll have 5G, 4G, 3G coverage. The narrowband IoT network that I talked about actually has a much wider coverage range than 5G, 4G, 3G. So those mobile towers that you see up with the Telstra towers, there's the same antennas actually also do narrowband IoT and Cat M1. And like I said, they can actually go 120 kilometers from a tower. So if you're somewhere that doesn't have 4G or 5G, but you think there's a tower, within 100 or so kilometers, you can actually, so these are the Arduino devices that I just showed on the screen before. You can grab one of these with a narrowband IoT SIM and you can test if you have coverage there. I can probably put a link in the channel as well, where you can actually see if you've got narrowband IoT or 5G coverage. There are also other partners that work with Telstra to actually help extend the coverage in areas where you might not get 5G, 4G, 3G. So there are always options. But firstly, I'd look at IoT. So that's all the questions that I have in the chat right at the moment. But what I'll do is, if you have any questions that come up later, keep going in the YouTube chat or find us on Slack. I had asked a question about Slack again. Maybe one of the GovHack presenters, do you want to answer that question about how to get onto the Slack channel? Maybe we'll say that to the end.
Yeah, maybe we can just share in the chat a link to it.
Yeah, good idea. All right, I'm going to stop sharing my screen now and hand it over to the lovely Val from Microsoft. Yeah.
Awesome. Well, thank you, Michelle, so much. Hi, everyone. My name is Valeriia Savenko, and I lead Internet of Things at Mixed Reality for Australia and New Zealand. And today I'm going to talk for the next 10 to 20 minutes around how you can maybe use Azure during the GovHack to help you analyze some of the data that is coming from all sorts of different IoT devices. So just to get started, at a high level, there is a free way for you to get started with Azure, and Azure is a Microsoft cloud. We offer $200 USD of Azure credit, and actually a lot of services have also a free tier, which means that you can use them up to a certain amount for free, because they have sort of an initial limit for messages. So if you want to experiment, you have a few days before the GovHack, and it should be within the 30-day mark. You can already go and create an account and start playing with a few services. I think for the next slide, I'm actually thinking of changing it now that I saw Michelle present, and extending it to the network and some of the bits and pieces that she mentioned today. But at a high level, Azure or any other cloud providers is helping you to get some of the insights, and then that leads to actions from your data. So if you think about maybe an agriculture scenario, a smarter irrigation system, you might have moisture sensors in the soil that can read information and tell you, all right, well, throughout the day, this is the moisture soil value, and this is how it relates to temperature. So you can maybe analyze the data and understand when is the best time to water your crops and things like that, instead of just going there every day and watering. So you can do it more on a scheduled basis. So this is kind of the actions and the insights. In Azure, we have a few services that can help you achieve some of those things. I'm going to take it at a very high level, assuming you do not have a lot of Azure experience. And if you do, that's awesome. Connect with me over Slack, where you can, I think Michelle at the start shared my Twitter handle if you do have any more questions, and I'll be mentoring the GovHack as well with a few of my other colleagues, so we can help you with more stuff that you can do in Azure. But if you're very new, there is a few services that I would like for you to have a look. When you think about things, insights, and actions, things are your devices, which Michelle has mentioned. You can order the Telstra developer kit. There is other smaller Arduino boards, as well as you can find a lot of different simulated devices online. And then somehow you need to get the data into the cloud. In Azure, we have a service called IoT Hub, which is like a cloud gateway that exposes a net point that your device can connect and stream the data in real time. And then after that, once you have the data in Azure, maybe you want to transform it, maybe you want to aggregate it with other data sets, or maybe run live stream analytics over it. So we have different services like Azure Functions, Time Series Insights, and Azure Analytics. And once you have those insights, you want to have an action. Maybe you want to have a mobile app or a web app as part of your as part of your kind of competition submission to be able to present the data. So we're going to go through some of those services. So I've narrowed it down to 4, and it depends on 2 scenarios. If you are as part of your competition, will be using a real device that is streaming the data, and the other scenario, if you're using one of the open data sets, and maybe it's a CSV file, and how you can get the data into Azure and run some analytics on top of it. So first of all, we have Azure Storage, and kind of the name speaks for itself, is your cloud storage solution for your data scenarios. You can store different non-binary objects, could be structured and unstructured data. You can interact with it over HTTP and HTTPS, as well as it has a few client libraries. So depending what language you're comfortable with, as you can see, it goes from .NET, Python, PHP, and things like that. Then next, we have Azure IoT Hub, which I've mentioned. This is our cloud gateway service that is capable of bidirectional communication. So you're not just sending the data from your devices, which could be temperature, humidity, velocity, like whatever that happens to be, as well as you can send commands from the cloud to your device. So for example, to shut down. It also supports different client SDK for C, our favorite language for microcontrollers and things like that, C#, Java, and Python, multiple protocols, as well as built-in message routing. So you can route the messages to different endpoints for processing. And it integrates really nicely with all of the other Azure services as well. Then we have Time Series Insights, and sort of Time Series Insights is a fully managed, open and scalable end-to-end analytics platform. You're able to explore the historical time series data. You can run rich analytics on top of it, create visualizations and things like that. So it kind of helps you to do real-time exploration using the recent Gen 2 Explorer. And it also has different connectors for things like Power BI. So if you are a Power BI user as part of your organization, maybe you can have a look how you can integrate that into your end-to-end platform. And the last but not least is Azure Data Explorer, which helps you to explore the data at scale. It has inbuilt high-performance data analytics, where you can do analysis of a lot of data, of different heterogeneous data, where it's structured and unstructured. It's part of our PaaS services. Actually, all the services that I've mentioned are platform as a service, which means that you don't have to provision the compute or worry, the size of the virtual machine and how much it has to scale. It all comes out of the box when you select a tier that you create the service under. It also has some machine learning capabilities, things like anomaly detection and forecasting. So if you are not an ML expert, you can use some of the out-of-the-box model to play around with the data during the hackathon. I have created a GitHub repo just because we were short on time, and I've tried to create sort of all the services to help you get started. So if you just follow under my GitHub repository, it's all open. I have GovHack resources, where you can see the reference architectures, if you suggested resources, sort of how to get started, how to navigate to the Azure portal, and also we have a few MS modules that I've linked. So Microsoft Learn is a place where you can have a structured learning for a specific topic, and it's actually awesome. I've been using it to do my exam prep. So if we get started, let's kind of tackle the first use case. If you have a real device that is streaming some data. So I have this Raspberry Pi, Azure IoT Online Simulator. If you use a real Raspberry Pi, that is awesome. I have one under my desk. And all it does is that it's generating some messages, as you can see. So I've sent over now 1,000 messages, and it's sending is temperature and humidity readings. You can obviously have a real device. I then have my Azure portal. So if you're new to the Azure portal, this is how it looks. You can obviously interact with all of your Azure services using the UI, or you can use PowerShell, Azure CLI, just depends what you're comfortable with. I think for the demo purposes, having a UI is a lot more convenient. And I have all of my resources. So as I've mentioned, we have the Data Explorer, we have the Time Series Insights, we have the IoT Hub and the storage account. So for now, for demo 1, let's concentrate on IoT Hub and the Time Series Insights environment. So I have the device it's streaming something. So how can I connect my device to Azure? So in here, I navigate to my IoT hub and I can scroll down to devices. And I will have, I think, 5 devices that I have pre-registered originally. So as you can see, Raspberry Pi to Raspberry Pi 1. To just add an instance of the device, you just need to click Add a Device. You can type in the name. And there's different ways of authenticating. We support certificates and symmetric keys. And I think for the demo purposes, if you're just trying to experiment, have a go at using a symmetric key, it's relatively easy to set it up. So you can give the ID and then save. Because I've created one before, we can navigate to it. And all we need to copy is this primary connection string, which is going to have the key inside to securely authenticate with my device and an endpoint to connect. So you can just copy that and paste into your Raspberry Pi simulator. If I go back to my resource group, so we have the IoT hub, and then into my time series environment, all we need to do is just to connect the two. And you can do that by navigating to event sources. And it has a very easy drop-down menu. You can just come in here, click Add, and select IoT Hub or an Event Hub, which is Event Hub is one of our other event streaming services. So you can select IoT Hub, and it will populate what are the ones that you have in your subscription. You can add it. Once that is all done, and just for the sake of time, I'm not doing it all step by step, but kind of have it pre-built. You can then come in and open the Explorer, which I've done because I like sort of using Edge for time series insights. I'll just reload. And as you can see, I just needed to provide a connection string. I didn't have to specifically go and try to, share what is the schema, what is the specific data it is sharing. So if you're just, experimenting with data sets, if you're sending some time series data into Azure from all your devices, you can create a dashboard and look through the data just using the time series insights web view. You can come in here, as you can see, this is my Raspberry Pi. You can also declare hierarchies. So if you're maybe building a solution where you have different devices in different locations, right? You can have some in Queensland and Victoria. You can declare all those hierarchies in here. So I have Australia, Queensland, Brisbane, and 2 devices. You can come under here and set the time frame. So I think I was streaming for at least 6 hours. So I can come and say, okay, the last 4 hours, give me all the data, which obviously looks a little bit crazy. So if I just looked at the last 15 minutes, out of the box, you can do things like highlighting and view statistics, which gives you the average, the minimum, the maximum. As well as you can add multiple devices on the same plot. So if you want to look how one device compares to the other, maybe they're deployed in different locations, you can do that as well. So you can click on here and press humidity temperature, add, and it adds them on the 2 different graphs. You can play around with a few options. It could be shared, could be overlap. So if you're trying to understand what the relationships may be between one another, you can do that in here as well. And you can save and you're good to go. Then we can go to the second demo, which is using Azure Data Explorer to explore your data. I know I kind of have a look at the previous GovHacks, and some of the participants use some of the open data sets that are presented in CSV format, which you could definitely do that as well. So I will just navigate to the Azure Data Explorer. You create it in a similar way as you do with time series insight, just through the portal. And this is kind of the Data Explorer page that you land. In the GovHack GitHub repository, I've linked a few links for you to go and play around and explore and just understand how it works and fits together. So let me know if you have any questions. So I have just if we move back to the resource group. So we have the Data Explorer, and I've created the storage account. And storage account is just for me to upload my data set. I've downloaded a data set from this database, which has different storm events. So that could be hurricanes, tsunamis, droughts across all the different states in the United states, and then you can download it as a CSV file. So I have a container, which is under storm data. And this is the storm events, which is just a CSV file. I can come in here, and all I need is to give the Azure Data Explorer access to this file. And you do that by generating a SAS token. So we can do that. So let's just copy that. And if we move back to the, oops, that always makes it tricky. There you go. So under data management, you can import the data into Azure Data Explorer. So there is a few different methods you can do that. You can ingest the new data by just uploading a file. It does take a bit of time. So saving the time, I'll just say ingest the data from the blob, because I already have the file in the cloud. You click on it and it says ingest new data. It will load for a database. And then you can maybe name it, oops, storm data. Next, blob, and you just give it the link to your document. You just give it a few minutes to look at the schema. And then hopefully the demo works. And as you can see, this is the file. It gives you at a high level the preview, so start time, end time, episode ID. It gives you the state. It gives you the event type, whether it's a winter storm or a drought, and if it's injuries and anything like that. So it kind of has all that information. So you go to next summary, and you just give it a few minutes. So it ingests the data and saves it. And now we're going to look how you can maybe run a few queries to look at the data, create some reports, and things like that. It does take a few minutes. Hopefully the demo gods are on my side. Let's see if we have any questions. Well, there is a lot of chat. That is awesome. Let me know if you guys have any questions. Cool. So it has ingested the data, it has put it into the table, and we can just click close. And we can go and maybe we can start playing with the data. So this is, and it has my previews. I was preparing for the demo. So under storm data, we can play around with the data. What we can do is, number one, maybe query the top 10 events. I'll just storm data, you can highlight, run, and it's going to return me all of the storm data and the top 10 events. For example, we can create some simple graphs and reports and charts. I'll just use this name as I've renamed my database. You can run it again. And it creates a chart for you, right? So I'm looking, all right, well, give me all of the incidents that have occurred by state, where the event count is more than this, right? So if I, for example, delete this, maybe I'll want to look at all of the events that have occurred. As you can see, there is a lot of states that have had different weather events. While you're exploring the data, you can maybe want to create different dashboards. So as part of your submission, maybe you want to have a nice looking dashboard that shows a percentage, or maybe a pie chart. You can do that as well. So it supports dashboards. So under dashboards, you can see I have one, but it's quite simple to create another one. You can come in here, click maybe test. It's always tricky to name things in real time and trying to follow best practices. So you come in here, you can add a tile, and there's different tiles you can add. So you can add a data source. So this is just storm data, and we just need to enter cluster URL, connect, and apply. And in the similar manner that we so I just need to change that to storm data. You can run it. as you can see, it kind of outputs data. You can add a visual, and maybe you want a really cool looking pie chart like this. So it shows the percentage of how many times a certain disaster has occurred. All you can do is maybe apply changes and save changes. And that will appear to this. You can add different tiles, make it look a lot prettier. And with that said, I will come back to my presentation. Do we have any questions in the chat? Or Michelle, you've been answering, seems like all of them, which is awesome. Thank you very much. Awesome. All right, well, Michelle, do you mind giving a quick overview about the Telstra Data Hub?
Yeah, absolutely. So thank you, Val, for that as well. You're dialing in from Brisbane, right?
Yes, that's correct.
Yeah, it's cool to have, someone from Adelaide, someone from Brisbane working together with GovHack, and everyone on the chat is like somewhere else. I see some more people there dialing in from Queensland. You guys are probably wondering why Telstra and Microsoft are here together in the same presentation. Obviously, Val and I are both awesome and we love working together. But it makes a lot of sense, especially in the IoT space, because Microsoft and Telstra have a lot of synergy in the sort of innovation that we can do. And we do have an ecosystem of innovation that the two companies are working together on. And one of the things that we're working on together that I thought would be relevant to talk about today because of GovHack is the Telstra Data Hub in partnership with Microsoft. So the idea about the Data Hub is it's a living data ecosystem where you can actually utilize this platform to securely share your data with other people. So for the large scale benefit of digitization and the IoT to occur, we really need like government, industry, communities, individuals, researchers to kind of work together and use IoT insights as a center for decision making. So what the Data Hub actually allows is that secure sharing of data. So someone asked in the YouTube chat about the cybersecurity concerns about 5G for IoT. It's not just 5G and it's not just IoT. Whenever you're sharing data, you need to make sure that you have the underlying platform. So that's where the Azure platform comes in. So that's the data platform that the Data Hub is on. And then Telstra has built the kind of ecosystem specifically with the network where you can ingest data in and then securely send it out. So it's intelligent infrastructure that's doing cool things with the data. If you just go to the next slide. Cool. The idea is to standardize data as it comes in. So you have IoT farmers, like the examples we use at the moment are farming, weather, satellite data that comes into the Data Hub. It's then standardized and stored securely. We talked about the cloud infrastructure, the Azure data platform underneath it. Then it allows you to sort of like select who it gets shared with. So you could, for example, want that data to be available to regulators for things like managing how much water is being used. You could share it with universities who are doing research on that sort of topic. So it's kind of related to GovHack, obviously, because it's about sharing data and open data. But there are some data that you don't want to openly share. So open data is one thing, and that's fantastic, and that's what GovHack is all about. But this is something to consider afterwards when you think, okay, I've got all my data. I don't want to just put it up publicly for anyone to see because of things we were talking about before, like the cybersecurity and the sensitivity of that data. So that's probably all I'll talk about with Data Hub for now. But after GovHack, if you guys want to talk more about this solution, I can talk a bit more about it one-on-one. We've talked a lot about the Slack channel today. So in the YouTube chat, thank you GovHack HQ for sharing. I'm talking about the GovHack Slack. So that's where most of the online stuff will be done. But obviously, Val and I have shared our information. You can come to us directly through Twitter or LinkedIn or whatever to ask us. So you probably jump to the next slide, Val, if you like. I also wanted to do a cheeky plug for the regular meetup that I run every month with a couple of other developer advocates. It's called Azure IoT. So Val and I actually hosted one together when I was in Brisbane a few months ago. So we partnered with the Brisbane IoT community. So if you're interested in learning more as a developer or as someone interested in the Internet of Things. We used to be Melbourne IoT, but now, like, we're all over Australia, obviously. We actually have a meetup group, obviously, have a YouTube channel and a Discord as well. So if you have questions about the IoT projects you're working on after GovHack, then you can come to our Discord and have a chat there. So yeah, keep in touch throughout throughout GovHack and then after as well. I was here for GovHack last year. I was actually a participant the year before and the year before that. So it's like my 4th or 5th GovHack or something. I absolutely love it. So yeah, looking forward to working with you guys this year and next year. If you're watching this recording in 3 years' time, everything might be different, but I think the general concepts will stay the same. Yeah, so that's all I wanted to add. Val, anything else you want to add?
No, that's awesome. Well, thanks everyone for watching. We'll probably stay online in the chat if the live will continue until 7. So we'll answer any questions. And I'm really excited to see what you come up and build on the day, and really excited to help as well. So let us know if you have any questions. And yeah, enjoy the rest of your afternoon.